Hi, I'm Alfonso Lagares, and this is my Physics 2212 Lab 1 report. First, I'll introduce the lab, its goals, and the fundamental principles involved in it. I will then discuss the data collection and measurements taken during this lab. The results of the lab will be interpreted and presented through a VPython model. And finally, there will be a conclusion and a couple of questions. This lab focuses on the concept of charge and the interactions present between charged matter. The main lab's goal is to find the excess charge on a piece of tape that has been charged through friction. The fundamental principles involved in this process are Coulomb's law, which describes the force present between two charges, and Newton's second law, which states that every action has an equal and opposite reaction. It was found that the tapes are positively charged, having lost around 8 times 10 to the 10th electrons each. It was also found that tapes repel each other due to them having charges with the same sign. The first part of the lab consisted of understanding the behavior of a charged piece of tape. It was found that after charging a piece of tape, it would be attracted to a hand or a pen that had been negatively charged through friction. It was also observed that two pieces of charged tape would repel each other. It was thus concluded that the charged pieces of tape had a net positive charge. In order to measure the amount of charge on one of these tapes, a charged tape was suspended in between two objects, and another charged tape was placed directly underneath it. The tapes were brought together slowly until the first piece of tape started bending outward, meaning that the electric force on it was equal to the force due to gravity. This occurred when the two pieces of tape were 0.028 meters apart. This measurement was repeated 3 times to reduce random error sources. Assuming that the two pieces of tape had the same charge, the equations for the force due to gravity and the force due to electric field on the tapes were rearranged to solve for the tape's charge. This came out to be 1.3 times 10 to the negative 8 coulombs. Using this result, the total number of missing electrons on the tape was calculated. Dividing the total charge on the tape by the charge of a single electron, it was found that around 8.17 times 10 to the 10 electrons were no longer on the tape. The total number of atoms that formed the tape was also calculated, using the area occupied by an atom and the total area of the tape. This came out to be around 4 times 10 to the 17 atoms. This means that the ratio of electrons lost per atom of tape was 2.04 times 10 to the negative 7. The results of this lab were modeled using GlowScript, a Python framework. Some assumptions were made to describe the physical phenomena. The tapes were assumed to not be affected by air resistance. It was also assumed that the charge on them was concentrated on a point charge on their center of mass, and that both had equal charge. The model produced the result on the right. So you can see the gravitational and electrical forces cancelled each other out when the tapes were at 0.028 meters apart. Finally, if the sign of the charges present was switched, the interactions between charged objects would not change. What dictates the behavior of charged objects is not the specific sign of their charge, but rather whether or not they have the same or opposite charge to other charged objects. Handling the charged tapes as little as possible is important, because when handled, charge is transferred from the tapes to other objects, returning them to the original uncharged state.